Thanks for coming to our talk. We're going to be talking about QARK, a new Android static code analysis tool that we've created. I'm Tony Trummer. I'm with the military wing of LinkedIn, and this is Tushar Dalvi. We're both penetration testers at LinkedIn, obviously. Before we begin, we'd like to thank OWASP for their continued efforts to make the internet a safer place and for giving us the opportunity to tell you about our cool new tool. To keep our lawyers happy, we're going to state that our opinions are our own and not necessarily those of our employers. So why did we begin this journey? The reason we're here today is we want to introduce you to a tool we've developed called QARK, which stands for the Quick Android Review Kit. We decided to build QARK after surveying the available open source tools related to Android security and feeling that more could be done. So we took all the ideas that all the other tools had that we liked and added some things we thought were innovative, and then duct taped it all together with some poorly written Python, at least the parts I wrote anyway. The result then is an automated static code analysis tool and attack framework for auditing and exploiting Android applications. The primary reason for building this tool was to secure our own apps, obviously, but we wanted to share what we built with everyone else in order to help raise the bar for Android security. After all, since the less vulnerable apps there are, the less we have to worry about them attacking our applications, and the safer we'll all be as Android users. Minus, sure. One of QARK's core objectives is to provide users with informative, authoritative sources of information so they can learn and teach others around them about potential security issues related to Android applications. Again, trying to increase the collective security knowledge regarding Android apps. We wanted to make QARK available to everyone, so if you are one of those one-person shops, you can ensure your apps are secure as well, even if you don't have any security team or budget at all. We're sure there are some big-name static code analysis tools out there that you could spend money on that would maybe give you as good or better results than QARK does, but QARK's free and doesn't require any complex setup or pricey consultants to come and integrate it into your SDLC. As you'll see, it has some features as well that we've not seen in other tools. Obviously, we're not the only people interested in protecting Android applications, so we figured by open sourcing QARK, not only would everybody benefit from it, but all of you could help to contribute back to it and make it even better. So if we failed to look for a bug that you know about or failed to detect it, go ahead and let us know. Or if you're a developer who isn't scared to try to decipher my sacrilegious Python code, you're more than welcome to, and we're asking you to please contribute something back. So we can all make QARK as good as possible. Lastly, we hope that someone might look at this and say, you know, if these two guys could build this in a couple of months, maybe they could do more on their side. We kind of think it would be awesome if the App Store owners would say, you know, scan the apps coming into their app stores looking for potential vulnerabilities, maybe alert the developers or their security teams, or ideally alert consumers, you know, this is not a safe app, but that's probably a bit of a fantasy. So what are the top issues we're dealing with in the Android world? Unfortunately, the number one issue is fragmentation, and that's totally out of our hands, right? Due to the finger pointing between the OEMs, the carriers, and Google, we're left in a world where brand new devices purchased today would still be available or still vulnerable to stage fright, and may remain, and several other vulnerabilities, and may remain that way for years to come, in some cases without any way for the users to update to a secure version of the operating system. It's so bad that customers have actually resorted to class action lawsuits just to get updates. And while people will talk about prioritizing security, what does it say about the prioritization when those are the links that your customers have to go to just to get a fucking update, right? The flip side of that is, of course, you can't necessarily rely on the users to always perform the updates. When you do publish one, you may inadvertently ship a vulnerable app and have it remain out there for months or years while you're sitting there crossing your fingers or praying there's a mitigation on the server side that would protect them, even after you've already fixed the bugs because they simply refuse to update. All this obviously puts a premium on getting it right the first time, every time, because there are no takebacks, right? Another common issue researchers commonly discover are related to X509 certificate validation issues. There are countless applications that have been discovered that are vulnerable to man-in-the-middle attacks, and others that just say screw it and don't use TLS at all. Apple's taking an innovative approach to this where they're going to require HTTPS on all connections, and hopefully that will allow them then to validate that they're actually validating certificates properly. But with the frequent use of web views, there's problems that come in from the OWASP top 10. They're all still all too common, cross-site scripting, cross-site request forgery, et cetera. But in the Android world, there are some unique twists and thankfully, in some cases, limitations that the attacker is subject to. Additionally, we now have to operate in an environment where we have to assume the other apps on a device are malicious and they may attack us via various IPC mechanisms. So if we care about our users, we have to try to put mitigations in place even to protect against bugs in the underlying operating system itself, which is kind of a unique paradigm that didn't exist before, mostly due to this fragmentation phenomenon that I was mentioning earlier. Also, when I grew up in IT, we had a saying that if you lost control of your computer, physical control that is, it was no longer your computer. But the common reality is that's not really the expectation with mobile devices, partly because they're more prone to being lost or stolen, and they're always on you, so they're more prone to being inspected by law enforcement, customs, those sorts of things. So it's a different kind of expected level of physical security. And despite strides towards improving physical security on Android devices, again, mostly due to fragmentation, we still live in a world where they don't all have hardware-backed encryption storage, and they don't all allow for strong authenticators like on the screen lock passcodes. Unfortunately, many applications continue to unnecessarily store PII and other sensitive information in the applications and even after the users log out, usually because they simply don't want to make another network request when the user logs back in again. But from a security perspective, we don't think that's necessarily a worthwhile trade-off. And finally, we have those developers like the dog here who can't seem to get it around their head that the fact that apps are reversible and everything you put in them will be eventually discovered by an attacker. So there's always API keys and things like that that are hard-coded into the apps that people will discover. There have been a countless number of bugs reported publicly about this sort of insecure data either embedded in the app or stored client side. But as one of our colleagues said, those bugs are mostly lame. And while QARK does include some tests for that type of issue, they're not the primary focus of what QARK's after. So again, to the motivation, why are we going through the work to make a tool like this? Fundamentally, as you know, most pen testers are lazy. At least in the sense that once we understand something, we want to automate it out of existence, right? We don't want to keep going back and finding the same bug over and over again because it gets boring. We want to go off and do something more interesting. So unfortunately, we have a crazy boss, and he expects that every time we ship an app to the public that it's secure the day it goes out and it's perfect, right? So we have those constraints we have to deal with. And with the pace of development, that's often challenging because we could basically devote a pen tester full time to just trying to keep up with the new code that comes out, and that would be their whole job, is just cycling through the new releases. So in our company, we have roughly 7 Android applications currently in the marketplace, so we have a lot of code going out every day that we have to check. Keeps us quite busy. And we wanted to automate things to kind of handle this and stay with the agile development models that our teams are using to push this code. So unfortunately, we know that our developers oftentimes are even lazier than the pen testers. And what I mean by that is, some of these IDEs will warn you about the bad things that you're doing, but they just go ahead and do them anyway, or they just, in worst case scenario, will just turn off the warnings, right? It's my understanding that that's how the go-to-fail bug actually made it to production, is because the developers at Apple just said, I don't want to have that check anymore in my IDE, and they just turn it off. Point being, we can't rely solely on the potentially false assumption that these checks are being performed on the IDEs and that the developers are actually acting on them when they do see them. Again, we hate repeating bugs, and as I mentioned earlier, once we understand a bug, we want to get it fixed, and we want to figure out a way to automate the checking for that so it never happens again, right? If there's one thing we can't stand, it's like, you fix a bug only to have another developer introduce it somewhere else, and you're just like, oh, why am I dealing with this same bug over and over again? So the other case there is, they put out a fix and they bundled it in with some other non-related fix, and then they had to roll that back, and then you got a regression bug, right? Lastly, many of the widely installed apps are developed by very small companies, like the Angry Birds or something like that. They might start off as like a small company and then just explodes, right? So these apps, even though they start off small and developed by these one-person shops, they end up on millions of devices and eventually. And the tragedy is that most of them haven't been subjected to even the most basic security review. These apps potentially as well, with all the startups around in this area, they may end up integrating with us at some point in time. They want to have some sort of partnership or connect to our applications. So we'd like to help them protect themselves so that if ever they get to that point where they want to integrate with us, we'd at least have some baseline of security for everybody. Because if they did integrate with us, eventually it would put our member data in jeopardy if we were to allow that. So under the hood of QARK, well, first of all, QARK grew very organically. We essentially had our own manual testing process, right? We basically go through things and we'd kind of create a checklist and then try to automate this checklist. And so it grew very organically using the rigorous but lesser known, oh yeah, we should add that to method of development. We didn't necessarily reinvent the wheel for the basic functionalities, but we chose instead to leverage what was out there whenever possible. We happened to luck out and find a Java tokenizing library called PLYJ, which we use to process the Java files, the venerable beautiful soup and MIDI DOM for the XML files. And while PLYJ does have some issues with some of the Android constructs, it is the best thing we could find, and it works pretty good. So again, it's all glued together with Python, and you'll notice that we list here several different decompilers. Tushar will talk to you about what's going on there and why we have to use so many. And lastly, we instrument the Android SDK in the exploitation phase, which Tushar will also demonstrate shortly. For those who are new to Android security, essentially if you take an app off of a phone and you blow it up, this is what you're going to see. Or inversely, this is what gets compiled in. It's essentially, an APK file, and it's effectively a compressed archive consisting of the directories and resources listed here. Many of these have relevance to security, but for QARK's main focus, we're going to concentrate on the top middle there, the Android manifest.xml and classes.dex file. There are some exceptions to this structure, primarily for like a Samsung or a Sony or someone who wants to build an app specifically for a specific device. They'll do some hardware optimization that's not covered by QARK, but this is the stuff that you and I are building as non-OEMs, right? So the other files, while important, aren't of concern right now for QARK. Maybe we'll dive into that later. But for those that don't know, the Android manifest.xml defines all the app's capabilities, its components, which versions it supports, whether the app's debuggable, whether a person with physical access could create a backup of it, and also just generally the application structure, which we'll cover in a second. It also covers which permissions it uses or declares, and again the versions that it was meant to run on, which becomes important when you're trying to deal with how you secure it on a given platform. To begin testing an already built Android app, what we generally needed to do was first get the manifest. We'd run APK tool and extract the manifest. Then we'd decompress the archive. Once decompressed, we'd have the classes.dex file, which is the Dalvik bytecode and not human readable to anyone that I know of. We used to then need to convert the Dalvik bytecode into the jar file containing the Java bytecode, and then we'd finally have to use JD GUI or something like that to retrieve the underlying Java classes, and we'd finally get back to something very similar to what the developer had written. This is assuming, of course, that the decompiler did its job in a reasonable way, which isn't always the case. And don't worry if you didn't take notes on this process, because QARK eliminates this, and you'll never have to manually reverse a normal Android app again. So in addition to that, QARK handles pulling the APK off of your device for you. So if you don't have, if you're not getting it out of your build system or something, or you want to test an app, somebody else's app or something, or an app that was already installed on your device, it'll go ahead and acquire that for you. So you don't even have to know how to use ADB. And if you don't know how to use ADB, don't worry about it. QARK will teach you that as you go along. So we will go on ahead and Googled it for you ahead of time. These features alone are enough reason to find QARK useful, but that's not the end of it. Once it's acquired and decompressed the APK, it parses the manifest immediately and begins reporting any findings that it finds. I'll let Tushar show you the details of that part, and then the functionality in that first part is similar to something that's already out there, that they have as an attack service functionality, but we went a little bit deeper into it to make it version specific and let you know how the app will look depending on the API versions you want to support. Before you can actually properly audit an Android application, of course, you have to understand where all the sources of potentially tainted data or attacker-controlled data may come from. This could come from malicious websites in the form of web content, you know, the OWASP top 10 type bugs inside of web views, or deep link URLs that are meant to spawn your application and pass things in through URLs embedded in different web pages. There's also these IPC mechanisms, which we'll get into a little bit. This is kind of the core of what QARK is looking for. Essentially, these are ways in which a malicious application on the device might speak to your application. They include intents. You have the AIDL or messengers that wrap AIDL, which are essential for marshaling data from applications on the operating system and through Binder. And let's see, you have network requests, as we said. There's actually been devices, someone wanted Pwn to own off of a simple unencrypted network request where they were able to jam some JavaScript in there and bad stuff. So these are the different areas in which a malicious application or website could inject data into or potentially launch an attack against your application. So these are the major components of your application if you're not familiar with Android development. After you reverse the app and got the manifest, what you'd find is there's different components declared in there, right? And these are the different component types that you're going to see. Activities are basically all the UI elements, all the little things you tap on, all the web views, all those things, right? Just basically, if you can see it, it's probably an activity or a fragment. Fragments are essentially similar, but they're not a declared component, so I skipped over that. And then let's see, services are basically the background things, right? They run under the hood, and you don't ever really see what's going on there. Activities providers are essentially either like a SQLite database or a flat file database, something that's going to store persist data over time, right? And the receivers essentially are like most of you at security conferences, just kind of hanging out waiting for someone to talk to them, right? They're essentially listeners, right? So each one of these has a different life cycle where they transition through different states as you play with the application or as you're using the application, right? So it's either waking up, it's starting, it's stopping, you know, it's going into background, it's coming into foreground, those sort of things, right? So all of these are represented by these different life cycle methods, and while they're not all listed here, I'll kind of give you an idea of the major ones. And in most of these, you'll find a core thing, which is on create. So when that element is created, that's essentially how the data flow starts, right? So if a malicious application were to send you an intent, it would actually come in through that on create method, and then you can follow that flow. That's essentially what QARK does. So initially, since we got the basics out of the way, once we define that attack surface through the manifest and we've looked at these components, QARK begins tying it all together, right? It takes the information from the manifest and then finds the classes which map to those in the manifest. For those that don't know, there's a direct relationship between the component names in the Android manifest.xml and the underlying class files. So for example, if you have a foo activity declared in the manifest, somewhere on the file system you will find foo activity.java. So it's easy to trace what entry points come to what classes, and then you can start looking for like the onCreate method to start following the flow through there. From here, QARK begins parsing all the classes and locating those entry point methods as they are the point where an attacker will introduce malicious application or malicious data into your application. So once we've identified the sources of tainted data that we talked about, we'd attempt to follow them through the code, looking for where it passes through what we would consider a sensitive sink. So some method that does some sort of sensitive system operation. Essentially, we're looking for anything that might like access a phone capability, that sort of thing, modify data, write data, retrieve data, that sort of functionality, or something that requires a special permission that the attacker app maybe doesn't have. And since not all the vulnerabilities are evident from the outside in, QARK continues to the examination process by looking for things that might originate from within the application. So these are like data leakage type phenomena where you might be sending information out or reaching out to get something and pulling it back in yourself. Also, there's these things called sticky intents where or broadcasts. You have broadcasts that will just send information to everything on the device, and you have these sticky broadcasts that will basically do the same thing but remain persistent. There's also things called pending intents, which go out and they will allow certain applications to actually operate with the UID of your application, right? So you can imagine how that might be a dangerous thing. And then for the web view issues, QARK includes a set of HTML proof of concepts so that you can actually look and see what these type of vulnerabilities would look like in your application. So they're templates inside the application, so you can either load them directly from our application, or you can pull them out of the source code, or you can go to our website where we host them. So maybe you want to host them on your own environment or anything. These include things like same origin bypasses that have been published from like Rafe Blaylock and these folks, so that you can actually see and verify that your apps might potentially be vulnerable to this sort of thing. And with that, I will let Tushar demonstrate what QARK can do.
Thanks, Tony. So let me change the mirror display. All right. So before we begin the demo, let me talk a little bit about the installation process. So we have tried to keep it fairly self-contained in the sense that all of the dependencies are included by default when you download the source. The only thing that you would need to provide as part of the setup is the actual location to the Android SDK. So if you are an Android developer, you already have the Android SDK on your system. So you can just point the location of the Android SDK to the tool and you're ready to go. But if you don't have the Android SDK with you, QARK actually makes it easier for you, and it gives you an option to download and set up the SDK for you and save this configuration so that you don't have to repeat this process every time you run the tool. So that being said, all you have to do is run Python QARK and you should be ready to go. So as QARK starts, you would notice that the flow is quite simple. As a starting point, you get the option to either pick an APK or start scanning the raw Java source code. So in both cases, the code flow is the same. The only reason why QARK gives you two different options is because if you are an auditor or a pen tester for your company and you want to take a holistic view of the security posture of your application, you would want to select the APK. And if you're an Android developer and you want to run checks on your source code as you keep adding new features to the application, you would want to start scanning the source code. So for the demo, let's choose APK. So at this point, you have the option to pull the APK off of the device. And this feature actually comes quite handy when you don't have the APK listed in the App Store. For example, the pre-bundle applications that come installed on your device. So I have the device connected to my computer right now. So let's go ahead and pull the APK off of the device. So you would get a list of all the installed applications. And since we don't want to get sued and we don't want to drop an ODA on someone's Android application, let's choose the OWASP Code Droid for now. That's 141. For those of you who do not know what GoDroid is, it is essentially an Android application which is left intentionally vulnerable for educational and research purposes. So you would notice that QARK tries to take the APK off of the device and deflate it and has processed the manifest. So if you say inspect manifest, it gives you a quick overview of the manifest. And you would recall that the Android manifest is the most interesting part of the application because it kind of gives you an understanding of what's within the application, right? So like what kind of activities, service providers, content providers exist, whether they can be called from another application, what permissions are needed by this application to run correctly on the device, what permissions are required by other applications in order to speak to this application, and so on and so forth. And you also have the ability to specify which specific versions of Android operating systems your application would eventually land on. And you may have some issues with those particular operating systems. So we have version-specific checks for those as well. So if we continue, you see that QARK has started gathering some intelligence about the possible threat attack surface. And for example, as Tony talked about, we have some backup issues, and the debuggable flag is set to true, which may lead to data exfiltration and some other issues, as we can see. We can also see that there are certain activities that are exported and are not protected by any permissions. So we'll save this information for the exploitation phase. Again, you can see that there is at least one service and one receiver that are exported and are not protected by any permissions. So we'll keep saving this information and move forward. So if you began scanning the raw Java source code, you already have the entire Java source code to go ahead. But in case of an APK such as this, we actually need the raw Java source code. So we need to go to the APK and move it from DEX to class files and class to Java files in order to do something meaningful. So what we have done here is that you can see that QARK is actually running multiple decompilers on the same jar file. And we do this because there are cases where a certain decompiler may not be able to decompile all the files correctly, whereas some other application or some other decompiler may be able to decompile those files correctly. So the idea here is that because each decompiler fails in a predictable way, we can leverage this fact to identify which files are corrupt and see if the other decompiler was able to decompile those files correctly. So for example, because of this technique, we were able to restore 11 out of 13 corrupt files. And that's almost, 85% in terms of recovery. So we have inspected the Android manifest, and we have the raw Java source code with us. So at this point, we can actually start the static code analysis. So all of the headings you see here are actual checks we run on the decompiled source code to find for those type of vulnerabilities. And we are actually going to be showing you the results shortly, and the results are going to be color-coded to kind of give you a sense of confidence we have in the results. So included in these checks are the standard Android lint security checks, some security research done by industry experts and subject matter expertise in this field, and also some research that we've done of our own. So we are still looking for more type of bugs to find, and we have certain issues lined up in the roadmap. But if you guys have any suggestion that we need to add, we are more than happy to include it. So let's see what information we could gather. So each of these entries reflect what entry points we found from the manifest declaration, and if any vulnerabilities were found in those specific files. Because at times it is important to realize whether we scan for a file and we don't report an issue. So it is important to realize whether something was not flagged as a vulnerability because there were no issues found in the application, or the decompilation failed and we couldn't scan the file. So for example, we found that there is an activity defined in a particular class, and it actually sets a result. So your app may leak data through this if some other application tries to speak with it. Again, we'll save this information for the exploitation phase. So because we are not trying to sell you anything, we don't want to give you a false sense of security by hiding errors in the application. So we will show you errors on the terminal whenever we couldn't pass something correctly. And we would also save this into a good report you would see later on, so that the developers can take a look at those specific files and scan them manually for any type of issues. So this is where things start getting a little more interesting. So as you can see here, we have actually found a real vulnerability. And more than just listing what exactly is wrong with that particular component, we went ahead and we have identified what exactly will it take for a different application to exploit this vulnerability. So for example, in order to exploit this, we actually need to send an intent with the key phone number, which is of type string, and message of type string. So QARK builds on this intelligence as it's going through all the files, and we save this for the exploitation phase. Again, there were no crypto issues found, no broadcast issues, which is good. We did find a bunch of certificate validation issues, which you can easily check. We have given you a reference of how to check for certificate validation issues. So the other interesting part that QARK provides is as soon as it finds a web view within the tokenized file, it's going to see what exactly the web view is configured as, and there are certain insecure by default configurations for the web views. So even if you have not set it, we report it, and you can take a look at it so that you can take an educated guess as to whether you should fine-tune that setting further. So we'll list all the web view issues here. And then this is where things start getting a little even more interesting. So we went through the Android manifest, saw the exported activities, some sort of issues that could potentially occur. And here is the real question. Can another application actually exploit these vulnerabilities, right? So for that, we are going to give you a couple of options. The first is, wherever possible, we'll give you ADB commands that you can actually run on your computer when your device is connected to it in order to see if you can exploit those vulnerabilities. And you would see that in certain cases, we even give you the extra key value pairs that you need in order to do something meaningful with that activity or exported component. Again, you would see errors wherever possible. So the interesting area to focus here is that even though we were unable to pass the decompiled file correctly through the PLYJ tokenization, we fall back to the regex mechanism, and we are still able to gather some intelligence about what potential exploitation could occur because of those specific issues on those files. So the second option is to actually go ahead and create a custom APK for exploitation. So if you enter that, it's going to use all of the intelligence it would gather during the exploitation phase, the static code analysis phase, and it's going to use it to feed data into a templated APK to build on the fly a custom APK that you can install on your device and exploit the other app. So it should build fairly quickly. Think of this as an evil twin for the application that you're just testing. And success, nice. So let's go ahead and install it on the device. And done. So Tony will demonstrate on the actual exploitation phase, but before that, let me talk a little bit about the headless mode. So if you want to do this automatically in a scriptable fashion, we have a headless mode where you can just specify all these configurations, and you can do start to end without interactive mode. The other thing is a report, which I will show shortly after the demonstration of the video. We need,
Okay.
cannot do it on mirror display.
So thanks, Tushar. While we'd love to show you on the phone, we know for a fact that these display cameras don't work well on the phone. So we've recorded a video. So this app here, the little Q, is QARK. And essentially, when you open it up, you'll be presented with this menu. And this basically attempts to give you several options on things that you can look for in your application. Obviously, in this case, we actually found a vulnerability, so that will be built in here, but there's some generic stuff in here as well. So we're going to start at the bottom, and the bottom was the custom intent sender. Whoops, I guess I went back too far. I apologize. Demo fail. All right, so you see at the bottom, send a custom intent. So any penetration tester, any application security person wants the ability to play with things themselves, right? So we may not have automatically detected it properly, or maybe we didn't build it the way you wanted it built, or you got a cool exploit that we don't have. Whatever the case is, you want to be able to create custom intents and send them here. Well, we've not only given you the ability to do that, but we also try to make it as easy as possible by pre-filling out a lot of stuff for you, or giving you these like drop-down menus, so you can specify the action with just a single click. You don't have to sit there and type with your little keyboard, you know. So the default actions will be there. Different categories are already there for you. Common keys. And then we have the capability here, since maybe we missed an extra or something along those lines, you can use the little plus button to add additional key value pairs that you can populate with intent extras. So if you have another piece of data you want to send to the application. Again, it's for manual testing or for some other type of verification that we didn't think of. So because when you send an activity, the expected process on the other end, what the victim application is going to do will vary. We allow you to specify that so that we know how to handle it when it comes back, essentially, or we know how to send it for you. So if you want to start an activity on the other side, or whatever the case is, bind to a service or something like that, it's going to handle that for you. So there's the different types it will handle. Some of them are still under development, but that's the general idea. And here, you just press send intent, and now it's not a bug that it crashed. What it is, by default we didn't specify anything, and by default in Android, if there's nothing to answer for it, your app will crash unless you catch the exception, and we didn't catch the exception when we had recorded the video. So it just pops right back up again. So going on to the next thing, we have a basic file browser. Anybody needs that, right? Just so you can go through this. And this is really just so you don't have to go get a different one to play with while you're using this. It's all in one place. Nothing special there. It's just going to show you the files. And that will allow you to see, like, if you have the SD card and you want to see what did you store on the SD card from your application or something like that, right? You can go through and see the listing of whatever files are available there. The next function here is the web view tests. Now I stress test because these aren't tailored to your application. These are templated HTML files that you can use to view in your own application, right? It's kind of hard. We may not be able to actually send them into your application. You may have to host them on your site or host a link to them off of your site or something like that to see their full exploitability. But what we do is we just give you these templates so that you can see what they look like in a vulnerable app. So it's sort of like a web goat in that sense, right? But we just want to let you see what it would look like if it were vulnerable, and then you'd be able to see if you're, confirm it in your application. So you'll notice that there's two for each, and this is because in the Android world, there are two web view clients. There's a Chrome client and then the AOSP or stock Android browser, right? That's kind of fallen out of favor in Google's mind. But they have different behaviors, and this is very evident as I skip forward. There we go, ruin the surprise. Yay. Sorry. Clicking on these little slider bars. Okay, so in this case, we're looking at something under, I believe it's the let's see, which one did we get? I apologize.
The Chrome plan.
It should say on here somewhere, right? So we'll find out in a second. So this whole POC is for two things. It's to show you that JavaScript is enabled, right? So whether JavaScript enabled is a vulnerability or not, I mean, it just really depends. Like, it's kind of like, if you don't need JavaScript enabled, don't enable it, right? If you can just show static HTML, show static to HTML, and then you don't have to worry about cross-site scripting. But more importantly here, at the bottom you'll see that there's a button that says click here. All this is just alert one, right? It's basically just your standard run-of-the-mill XSS check. So the interesting thing is when I clicked it, you didn't see it there, but it did nothing, right? A limitation of a video. But, sorry. This is the exact same file. Oh, sorry, I apologize for the lack of video demo skills here. But this is the Chrome client, and in the Chrome client, it will fire. The point here is we're trying to show you that the alert functionality is actually disabled in the AOSP browser. So if you're doing XSS via the alert functionality and you didn't realize that, you've got a false positive on your hands, right? Because you didn't realize you were being spawned in that browser, and it didn't actually allow you for the alert function. So you might want to try to do something other than alert. So in this case, we clicked the click here button, and it worked. Again, it's the same exact file. So there are other things there, like whether or not you can access file URIs. Again, Rafe, God, I'm just failing really bad at this, running this thing here.
Keep pausing and just
Yeah, so whether or not you can access file URIs, whether or not there's the Rafe Blaylock same origin bypass towards the bottom there. Base URL, which is basically, did they redefine what domain is going to be reflected in the web view as you're looking at it? So you can actually set, you could actually set the domain to be like foo.com, even though you're looking at something completely different. Those sorts of things. So tap jacking, most people will tell you tap jacking is not really a vulnerability anymore in Android because somewhere on the internet they told you that. This is a proof of concept that we stole from Envisium, and as you can clearly see, we're creating an overlay over this application and it's still functional. We can click the buttons and operate the application. So what does that mean? A malicious application can put an opaque overlay over yours and trick your users into doing stuff that you didn't want them to. So this is basically just spawning the different visual elements so that you can see that they are in fact being overlaid. The next thing is the intent sniffer. So we changed the language here to make it a little bit more clear in the most recent version. But essentially all this is doing is sitting there listening for data leakage. It's listening for broadcasts that your application is sending. So it's registered all the receivers it needs to based off of what it scanned out of your application. And if it finds some piece of data come across, it's going to report it here. And we really need to hurry up, it looks like. He said timeout, so I guess that means something we need to hurry up. So here's just a list of exported components. You can spawn them. You can see that we've extracted different extras that you need. So this helps you so that you don't have to guess at it, right? And the application behavior will vary based off of whether or not you send an extra and what extra you sent. Unfortunately, we are running really out of time here. So this is an example. If I send a username, it has one response. If I send something else, it doesn't. Another 4 minutes. All right. So anyway, which one?
it'll come up for this one.
Oh, so he queued it up here. So essentially,
Let it run.
just let it run. All right. So those are the different components we found that were attackable. You can select them. In this particular case, nothing came back, right? We spawned this component and nothing happened, right? In the next case, did I screw it up again? Anyway, in the next case, we actually specify something, and what happens is you'll see that the activity actually returns data to us. In this case, it's the session token for the user. I guess ham-handed with the mouse today, but in this case, is this the one? All right. So in this case, because we sent something to them, you may not realize it, but the activities, the visual elements actually have this set result feature, and they could actually return data to you. If you didn't have the extras there and you didn't send it in there, you'd never see the result, and you wouldn't know that some other app could have stolen that from you. So I'd be more than happy to share this with you. I'm sorry, I'm running out of time here. In this particular case, the vulnerability that we highlighted in red, the one specific one, was that we noticed that the application would take a phone number and a message, and it had something to do with SMS if you looked at the component name, right? So any intelligent person would say, obviously, that has something to do with sending text messages. Now, our attack application doesn't have the ability to send text messages on the device, but the Goat Droid victim app does. So in this scenario, what we're actually doing is abusing the functionality that this application has. So we didn't have to declare the permission for it, and we can essentially proxy through them to do our bad deeds. Do you want to show it, or?
We'll show it this time.
Okay, so the last thing on the demo here, and I apologize again for us running out of time. Okay, that's it. So back to the presentation. PowerPoint looks familiar. We'll be out in the hallway afterwards if you want to see the demonstration that we botched a little bit here. All right, AV fail. All right. Okay, so just to recap everything that what we consider unique about QARK in particular is that unlike any tools we're aware of, it improves the chances of you decompiling the APK by using multiple decompilers and merging all those things together. It builds this APK, this custom evil twin APK for manual testing and has all this built-in sort of Swiss Army knife style functionality that any Android tester would need. Tushar showed you the ADB commands that will be output. Those are literally copy and paste into your terminal, and you'll be able to run them. It also breaks out some of the help menu functions, and it'll show you when we can't quite figure out what we're supposed to do there. We'll dump out, like, here's what you should do, and based off the data type, that sort of thing. All throughout that terminal output, there is URLs in those things that will point you to authoritative sources of data, like research, et cetera, kind of letting you know where you can find more information or the background of the vulnerability. So QARK is never going to be a forensics tool. That's not really what we designed it for. But it may someday be a dynamic analysis tool. We just haven't gotten to that point yet, since there are bugs you can find through dynamic analysis that aren't available through static analysis. It's not perfect. It's pretty finished right now. We have one bug that we introduced in between in the last 2 days or so, but we'll get that fixed before the end of the day here. And we're really trying to solicit you guys to use it, play with it, see if it finds a bug for you, let us know about it, see if it doesn't find a bug that you know you had, all those things. If you want to add modules to it, whatever, let us know. We'll gladly take any commits from you folks. I'm skipping ahead. We may, again, do some dynamic analysis. Smalley inspection, if you don't know what Smalley is, it's sort of that intermediate stage when you kind of go from the APK before you get to the Java. There's that Dalvi bytecode or the Smalley that you can play with and actually get a full picture of the application, but it's much harder to parse. So that's maybe coming. ODEX support possibly for OEMs, but that's like a small percentage of the market. We may try to integrate with like some sort of Java specific tool that finds bugs in Java, but that wasn't designed for Android, to find more general vulnerabilities. We've done some stuff to improve the extensibility so that you folks can contribute to it, and we're trying to make it as modular as possible. Shouts out to MWR Labs, kind of the starting point from this, with playing with their Drozer tool and wanting to improve on that. Rafe Blaylock and others for the WebView exploits, Invisium for the tapjacking code, all the people who wrote and maintain the open source projects that we use, and these folks, Jason Haddix and Sam Bone, and them for giving us some sample APK as a test against. You'll be able to pull this down right now. I would caution you to wait till tonight. And it's right there on LinkedIn's GitHub page. And lastly, if you wanted to contact Tushar or I, obviously we're both on LinkedIn. And if you have any questions, we probably have 0 minutes to answer them. Oh, yep, sorry. In my haste, I was trying to get out of here. So it's GitHub. It's just LinkedIn's GitHub repo. You can probably Google it if you don't remember it. Anyone have any questions? You, sir, with the awesome haircut.
Yeah, thank you. And it is not as awesome as your tool, though. So it's phenomenal, but I think it's more geared towards command line usage right now.
Well, Tushar never showed you the report. So it is geared towards command line usage for sure, but we try to make it dumb simple. Like, I mean, literally there's like 3 inputs and you're done. What do you want to do? What's the thing you want to look at? Where is it at? We're done, right? We produce a nice HTML report, which unfortunately we're out of time. We aren't going to be able to show you unless Tushar wants to do it real quickly. But it's also scriptable for a headless mode so that you can integrate it into your SDLC and never even have to touch the thing.
Yeah, that's what I was more interested in.
Are we going to build a GUI for it if we get some free time? You know, but it's not, like, honestly, it's not meant for like people who are like heavy terminal users. It's dumb simple.
Yeah, I was more interested in like looking at this, which could be very useful to build it into my build pipeline and say, hey, people are building stuff and then it's gonna build if they are not up to the mark in their code quality or things like that.
Definitely. So the requirements are you need to have Mac or Linux.
Yeah.
And you need to have Python 2 installed. That's it. It'll handle the rest for you.
Second quick question is this specifically geared towards full-fledged Android applications, or if I have only SDK or something I'm building as a library for Android applications, can I use it for that as well?
You can still run checks on whatever code you have. You may not get comprehensive results, but you can still find certain vulnerabilities with this.
Thank you, guys.
And you might want to just build a sample app with the SDK and then scan that.